Hello friends. In today's class we are going to talk about in an expression which associativity of an operator takes, and we'll see how it is implemented. Welcome again, and the next topic here is the associativity of the operator. So here some common operators such as exponentations are right associative, and as another example of the assignment operator is a right associative. Okay, so this is also an expression A equal to B equal to C is treated in the same way as the expression A is equal to B is equal. So now what is basically an associativity is see, if I do the parenthesization, I don't need to be worried about this associativity thing. Like suppose if I say A plus B multiplied by C, and if I put this thing in the parenthesis, then I don't need to be worried about that who will be first, who will be second. Associativity comes into the picture in absence of parenthesization. Okay, if there is an absence of parenthesis, okay, so there is an absence of parenthesis. Okay, if I don't have a parenthesis and then you want the evaluation order, then associativity and precedence, okay, because the topic is for associativity but also it is a related topic, is the precedence comes into the picture. Precedence, that will be the next topic. So in absence of parenthesization, the absence of parenthesization, order of evaluation, okay, order of evaluation is done by associativity and precedence rule. So if I ask you that like associativity A, let's start with this, A is equal to B is equal to C, so who will be first, who will be second? So by default, this expression is equivalent to, as the statement suggests, that is equal to B is equal to C. That means this part will happen first, and then a value will be assigned B from C first, and then that value will be assigned to A. Similarly, so here, what is the common way to understand this thing is the middle operator. Okay, the middle operator associated with left or right. So if it is a right associative, then this statement B equal to C will be first. And if the same statement is a left associative, then A is equal to B will be first. So that association of B, the middle one, is with which operator, left operator or right operator? And that decides the associativity and the precedence, associativity that decided by the associativity rule. Another example that I can give you is A plus B minus C. Okay, so now again we have a confusion that both left and right side there is a plus and minus operator. This can be resolved by precedence if I say that one of the operator plus or minus is a higher precedence, so higher precedence it will be associated with. But plus and minus is having same precedence. Okay, they are having same precedence. In that case, which one will be B will be associated with plus or minus? That again I need a associativity rule. Okay, and it is a left associative. So A in C language, so A plus B will happen first, and then finally minus C. Answer may differ. Answer may be same, but the core idea behind this is that order of the evaluation. Okay, so that is the associativity and precedence of the operator, and it's a core topic of C language expressions. The question is that who enforce this associativity and precedence rule? Okay, so this associativity and precedence, both rules, okay, associativity and precedence rules imposed by grammar. Okay, so the grammar decides whether it is left or right associative. For example, if I take an expression grammar, suppose if I take E derive E equal to T, E derives T, and T derives, suppose, an identifier. And now I just take this A is a identifier equal to another identifier is equal to C. If I just do this thing and I draw the parse tree, okay, so let me draw the parse tree. E equal to T. I need one more time another plus equal to operator. So E equal to T, and then E to T, T to ID, which is A, T to ID, which is B, and T to ID, which is C. Now this is the parse tree. Okay, now in this parse tree, you look at this this part B over here, that B association of B. Okay, the B is a part of this subtree. Okay, if I just put this thing in this dotted circle, that this B is part of this subtree. Okay, so B is a part of subtree. Which consists of left equal and and A. So it is part of left subtree, and what we can say for this particular grammar, equal to is left associative operator. Similarly, if I just change the grammar and I write here E derive T plus E, and again E derive T, and if I say T derives ID, and if I say now that E derives T plus E, one more time E derive T plus E, and E to T and T to ID. So this will be your ID, and this will be your ID. Now if you apply the same sentence, same concept over here, the middle ID basically this is A, this is B, and this is C. And if you see this, which subtree it is part of, so now it is part of right subtree, right, I have taken a plus operator, okay, fine. So if I say A plus B plus C, okay, I should have taken the same equal to, okay, let's change this one, okay, let's change this one to equal to. So this is equal to and this is equal to, sorry, in a flow I just wrote here this plus. So if you see this middle B, now middle B is associated with what? Middle B is a part of right subtree, okay, so B is the same context now changes. So B is a part of right subtree, B is part of right subtree, and equal to and C it is associated with. Okay, so now if you look at here, the middle B, it is part of your right subtree. So now the same sentence, if I write here A is equal to B is equal to C, this is a part of subtree, so this will be done first and then finally this one. Okay, so I can say what for this grammar, equal to is a right associative operator, right associative operator. Okay, so this is your how grammar decide left and right associative, left and right associativity. What you have to do here in this case is take a string with at least two, one will not give you, take a string with two operator, draw the parse tree and it should be unique. Okay, if you have two different parse tree, then it will not possible. So take a string and draw the parse tree, see which subtree middle operator is part of, which subtree middle operator is part of. Okay, so that you can say left, so you can say left associative, right, then you can say right associative. Okay, so that's all about this associativity of the operator.